All right, let's go ahead and talk about this. So today we're going to do concept 11, day 2. So now we're going to look at solving polynomial equations by grouping and then also sum and difference of cubes. So yesterday we talked about the difference of squares. We're going to add on today and we're going to work with cubes and we're going to do sum and difference of cubes. All right, so for this warm-up, it asks us to find the real or imaginary solutions for this. First step, always put it in standard form. So this would be x cubed minus 5x squared plus 7x equals 0. So the very first step is put it into standard form. All right, next, look to see if you can factor out a greatest common factor. So this one we could factor out an x, and so this would be x squared minus 5x plus 7 equals 0. Now let's check if this is factorable in our parentheses. So two numbers multiply to get 7 that add up to be a negative 5. Is that possible? Nope. So if it's not possible to factor, we're going to look at quadratic formula. So x equals negative b, so it'd be a positive 5, plus or minus square root negative 5 squared minus 4 times my a, which is 1, times my c, which is 7, all divided by 2 times 1. So this would be 5 plus or minus. We have 25 minus 28, and so this would be a negative 3 under here, all divided by 2. Square root of negative 3 we can do with imaginary units. So square root of negative 3 is the same thing as I root 3. So we can write this as 5 plus or minus I root 3 all over 2. Again, this is what x equals. Do our heart surgery on this. And then I'd like to see a final answer of x being 5 halves plus or minus I root 3 all over 2. And this over here, this x, do not forget it. So this x right here, also x is going to be 0. So x will equal 5 halves, I root 3 over 2, and also 0. Remember, the degree of our polynomial, we started out with an x cubed. So that was the highest degree. That tells us how many terms we're going to have. So x cubed, or I'm sorry, how many solutions we're going to have. So x cubed tells us 3 solutions. One is 5 halves plus I root 3 over 2. The other one's 5 halves minus I root 3 over 2. And then the third solution is x equaling 0. All right, so today, let's just do a quick recap from yesterday. So yesterday we practiced factoring out a GCF. Once we factored out that GCF, just like we did there in the warm-up, we can solve by factoring or using quadratic formula. Okay, whenever you're looking at a problem to factor, look for a GCF. If you can pull a GCF out, it'll make your problem easier. And then still, by pulling out GCF, we still might have to use factoring or quadratic formula. Factoring is more efficient if it is factorable. You can do it faster. But if it's not factorable, we have to use quadratic formula. We talked about doing that quartic to quadratic using a substitution. So if I had something that was x to the 4th plus 2x squared plus 3 or something like that, I could do my a substitution where I'll let a equal x squared. And now I can write this as a squared plus 2a plus 3, and then continue on and do it like a quadratic. All right, so that was that a substitution. And then also difference of squares we talked about. So difference of squares, if I have two things that are being subtracted, that means difference. A squared minus b squared is going to be a plus b, a minus b, always. Okay, or you can write it as a minus b times a plus b, it doesn't matter. But it's one addition, one subtraction. This is one that we need to become more and more comfortable with, because now if we recognize that we have a difference of squares, like if we had x squared minus 81, we could immediately jump to say, well, that's x plus 9, x minus 9. All right, because I know this pattern, it has to be that. Okay, so for today, we're going to tackle two new methods. First method we're going to talk about is called factor by grouping. So this one's actually pretty easy. This one's pretty straightforward, and this one's nice. It's going to help you out. Factor by grouping, we've already done a little bit, because if we had something like 4x squared plus 7x plus 5 or something, and we'd figure out our factors and split this up, and then we'd have 4x squared, and then we'd have something plus 5. Factor by grouping, we are going to be starting from here. So they've kind of already have done it for us. It's not completely the same because this was where if we were working with quadratics. Now we can have higher degree polynomials like x cubed or something, but they've already created these 4 spots where we'll create our parentheses, add those together, and then go from there. So we were already doing a form of this when we were factoring quadratics where a was not equal to 1. So let's look at one. If we had one as x cubed plus 2x squared minus 3x minus 6 equaling 0. And again, we want to solve. We want to figure out what x is. Again, they have these 4 spots already for us. So this is another method, another tool that we can add to our tool belt of how to factor polynomials. If it's set up in 4s like this, we can simply make it into 2 sets of parentheses and combine them with addition. And I always include that it's a negative 3x. I include that negative 3 in my parentheses, and then I put addition between them. But this, we just work the same way, where now we look at, well, can we factor out a greatest common factor? For this one, I could factor out x squared, and so it'd be x plus 2. I know this one has to be x plus 2 as well, and so if I brought out a negative 3, that would complete my line above. So that'd be negative 3x minus 6, still all equaling 0. And so my 2 factors that I will have are x squared minus 3 and x plus 2. All of that still equals 0. So factor by grouping, it's nice. It's kind of already a quarter of the way, a third of the way through how we did it with quadratics when a was not 1. It's not the exact same, but it's the same type of system in order to solve. Not done yet, though, because we need to figure out what x is. So I have 2 things that are being multiplied that equal 0. So x squared minus 3 has to equal 0, and x plus 2 has to equal 0. Well, this one's straightforward. Oh. This one's straightforward. It would just be x is a negative 2. If I were to solve x squared minus 3 equaling 0, well, that would be x squared equals a positive 3. Square root both sides, and I would have x equals plus or minus square root of 3. So my original problem was x cubed, so it's a degree 3 polynomial, so that tells me I'm going to have 3 solutions. My 3 solutions are a positive root 3, a negative root 3, and a negative 2. Okay, let's do another one for practice. 12a cubed plus 4a squared equals a negative 3a minus 1. With any of our solving problems, we always want to set it equal to 0. Set it up so it's equal to 0. So let's move the negative 3a and the negative 1 over. So this would be 12a cubed plus 4a squared minus 3, or I'm sorry, plus 3a plus 1 equals 0. From here, I'm going to do my groupings. So I have 12a cubed plus 4a and 3a plus 1. 12a cubed plus 4a, I can factor out a greatest common factor there. I could factor out 4a squared. So it'd be 3a plus 1. This also has to be 3a plus 1, which it already is. So really all I factored out was a positive 1. So I have 4a squared plus 1 times 3a plus 1, all still equals 0. But now it's in factored form. Now that I have it in factored form, I can figure out how to make each one 0. So 4a squared plus 1, if I want to make that be 0, that'd be 4a squared equals a negative 1. A squared would equal a negative 1/4. A then would equal plus or minus square root of negative 1/4. Okay, we can do a little more with that. We don't want a negative under the radical, so I could change that to plus or minus I square root of 1/4. Then, and square root of 1/4 is plus or minus I. If I'm taking the square root of a fraction, I could do square root of the numerator, square root of the denominator. Square root of negative 1 is, or I'm sorry, square root of 1 is 1. So it's going to be 1, square root of 4 is 2. So it'd be plus or minus 1/2 I. If we were to look at the other one, 3a plus 1, set that equal to 0. That'd be 3a equals a negative 1. A then would equal a negative 1/3. So again, I started with a degree 3 polynomial, 12a cubed. So it tells me I had to have 3 solutions. One solution is a negative 1/3. 2 solutions are plus 1/2 I and then minus 1/2 I. All right, but doing this by grouping, as long as we have 4 terms, we can do it by grouping. If there's 5 terms, we can't do it. If there's 3 terms, we can't do it. Has to be set up in this way. But if it is set up in this way, it makes it real easy. We can just do our factor by grouping, put parentheses around 2 sets, and go. All right, let's talk about cubes. Just like when we're working with all those squares, there are perfect cubes. So a perfect cubed is simply 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And we can continue on. Okay, so here's the start of a list of all of the perfect cubes. We are going to talk about sum of cubes and difference of cubes. So just like we had difference of squares, we're going to have 2 new formulas that deal with sum of cubes and also difference of cubes. And these are on that blue sheet that I gave to you. The last 2 lines of that blue sheet was factor by grouping, which we just did. Then also the sum of cubes. Okay? The formula for if I have a sum of cubes is this. So if I have something that's set up as a cubed plus b cubed, it's going to become, first set of parentheses, a plus b. Second set of parentheses, a squared minus ab plus b squared. But just like we were doing with difference of squares, we simply identify, well, what is a and what is b. Once we know a and once we know b, we simply fill it into our formula here and we're done. Or we'll get it closer to a factored form anyway. All right? So you just need to be able to know this, and there's an acronym that we're gonna go over here in a minute to help you remember it. We also have difference of cubes, which is a minus b in the first set of parentheses, and then a squared plus ab plus b squared. This looks like a lot, but it's not impossible to memorize by any means. Okay? If I have a sum going on, my first set of parentheses is a sum as well. Because I'll identify A and I'll identify B. So if it's a sum, the first set of parentheses is also a sum. The only different part is going to be this sign in front of A and B, A times B. And it's the opposite of whatever your original was. So if it's a sum of cubes, it's actually a negative AB. If it's a difference of cubes, it's a positive AB. A way to help you remember this. So the pattern for the actual signs, it's same, opposite, always positive. So when I say same, whatever I started with, so like here I have my sum of cubes, A cubed plus B cubed. So same means the first one is going to be the same. And then the next one is opposite. And then the last one is always positive. And the acronym to this is SOAP. So like FOIL is an acronym to use the distributive property and multiply two binomials together. SOAP is the acronym to help you remember the signs on these. So same, opposite, always positive. So your first set of parentheses is the same sign. And then you get into the sign on your AB, which is opposite, and then always positive at the end. Okay, so let's do one of these. If I had x cubed minus 8. So first off, we need to verify that it is a difference of cubes. Well, I see the first one is x cubed, so I know that's a cube. What about 8? Is 8 a cube of something? What is it, Ben? Okay, so 8 is the same thing as 2 cubed. So actually, I could think of this as x cubed minus 2 cubed equals 0. So therefore, what is my A and what is my B? What's A? Just x. Okay, because it's what is being cubed. I want that what is my A. And then B would be 2. So first off, identify your A and B, and then you can fill into your formula. It's a difference of cubes, so we're going to be working with this one up here. So my first set of parentheses will be x minus 2, x squared plus x times 2, which is 2x, plus 2 squared, which is 4. So this is factored form. X minus 2 times x squared plus 2x plus 4. Ultimately, we're going to solve these. Set it equal to 0. So if x minus 2 is a factor, what's x going to be to make it 0? Positive 2. All right, so we have one solution already. We know there's going to be 3 total solutions because this is a degree 3 polynomial. X squared plus 2x plus 4. Is this factorable? Are there 2 numbers I can multiply to get 4 that add it to be 2? My options for 4 are 4 and 1. I can't make 2 from that. Or 2 and 2. I can't make 2 from that. So this one is not factorable. So then I have to go for the quadratic formula. So negative b, so negative 2 plus or minus 2 squared 4 times 1 times 4 all over 2 times 1. Two squared is 4 minus 4 times 4, which is 16. So 4 minus 16 leaves me with a negative 12 under my radical. How can I write square root of negative 12 without a negative under there? What's simplest form that I could have, Thomas? Correct. So square root of 12, well, we'll bring the I out, so it's a square root of 12. 12, I can also say, is 4 times 3. Square root of 4 is 2, so it's 2I root 3. So getting back to my problem here, I have a negative 2 plus or minus 2I root 3 all over 2. Perform heart surgery on this. And I'm going to have x equaling negative 2 over 2, which is a negative 1, plus or minus 2 over 2, which is positive 1, I root 3, and then also don't forget about your x equaling 2 here from the beginning. So my three solutions are 2, negative 1 plus I root 3, and negative 1 minus I root 3. I have three solutions there. So that's solving using difference of cubes. Let's do one more with a sum of cubes. How could I write 64 as a perfect cube? What would that be? 4 cubed is 64, okay? Because again, this is 1 cubed, 2 cubed, 3 cubed, 4 cubed. So this is 4 cubed is the same thing as 64. What about 27x cubed? How could I write that as one term raised to the third power? Landon, what do you say? So what else is going to be my parentheses, though? 3 is correct. 3x. Okay, so parentheses are important. So I'm saying 3x quantity cubed is the same thing as 27x cubed. Okay, because remember our properties of exponents, when we are multiplying, that exponent is attached to each piece of my product. All right, so 3 cubed gets me the 27. X cubed is the x cubed that I want. So therefore, I know now that A is going to be what? What's A? 3x. What's B? 4. All right, so we have a sum of cubes. And so let's start working this one out. So my sum of cubes formula I have written up here becomes A plus B. So 3x plus 4 times A squared. Now be careful here. Your A is 3x. So it's helpful to use parentheses on this. So it's 3x squared. Don't write it as just 3 and then the squared on the x. It's quantity 3x that's being squared. Minus A times B, which would be 4 times 3x, which is 12x, plus B squared, which is 16. So now I'll take it a step. That 3x squared I'll actually work out. So that's 3 squared x squared. So that's 9x squared minus 12x plus 16. Again, all this still equals 0. Well, right away I can pick off this easy one. If 3x plus 4 equaled 0, then 3x would equal a negative 4. X would be a negative Now, this other one, 9x squared minus 12x plus 16, this one's going to take a little more work because this is the quadratic formula. Okay, so x will be opposite of b, so it's 12 plus or minus square root of negative 12 squared minus 4 times 9 times 16, all divided by 2 times 9. I will tell you that the discriminant becomes negative 432 all over 18. Okay, well, we know that if we had square roots of negative 432, we could write that as I square root of 432. We need to check perfect square factors of 432. Okay, and so this one gets to be bigger numbers because we're going to use bigger perfect squares. We can actually do 432 divided by 144. 144 is 12 squared. That equals 3. So 432, I could also write as the square root of 144 times 3. And so square root of 144 is 12 times root 3. All right, if I gave you more time, you could come up with that. Okay, but even these big numbers, we got just we only test the perfect squares. Okay, but keep going. Okay, 144 was 12 squared, but we can keep going to get to that point. So filling back into my quadratic formula here, I have 12 plus or minus 12 I root 3, don't forget the I, all over 18. Do our heart surgery on this. And so I'd end up with, we'll come over here. I'd end up with 12 over 18 plus or minus 12I over 18 root 3. What's 12 divided by 18? Can I simplify that? If I divide each term by 6, that's 2/3. So 2/3 plus or minus 2/3 I root 3 and x equaling a negative 4/3. So there's 3 solutions, which makes sense because it originally was a degree 3 polynomial. So x is negative 4/3 and x is 2/3 plus or minus 2/3 I root 3. So using sum and difference of cubes, recognize what each one is as a cube. That's your A, that's your B. Follow the roadmap and solve. Factor by grouping. If you have 4 terms already laid out, put parentheses around them and solve. Okay, so there is an IXL assignment. I'm aware that the internet is not cooperating today, so you can at least get started on the textbook problems that I already have up here, so you don't have to open up the textbook. Finish up that IXL tonight or whenever the internet comes back today. Hopefully you're still at school, it comes back on. Only to a 75, so that's not too bad. Have these ready to go due tomorrow, and then we'll talk about it tomorrow at the start of class.